5000. So it's hard to give what the n value through the keyboard. So what is the different options we have? We can read from a file, or we can generate it by using what a random number generator. Okay, so we can take the help of either a file or random number generator help. And after that, we need to demonstrate using Java how the divide and conquer method works along with its time complexity analysis. So we need to do the time complexity analysis here with respect to three cases: worst case, average case, and best case. Okay, we need to discuss much more in this lab assignment, and the same will be applicable for assignment number 4. Only one thing it's going to be differ in that assignment number 4. Instead of the sorting technique merge sort, there we will be using a sorting technique called quick sort. Okay, so that will be the difference. Apart from that, nothing is going to be a big issue. So try to understand things carefully. It will be helpful for understanding the 4th assignment. ಎರಡು ಸೇಮ್ ಆಗ್ಬಿಡುತ್ತೆ. Only you need to change what the sorting technique. Okay, ಇಲ್ಲಿ merge sort ಇದೆ. In that 4th assignment, we are going to talk with respect to a quick sort. Right? So anyone, can you define a merge sort? What do you think about a merge sort? ಏನಿರ್ಬೋದು? As it's been discussed in theory class on DAA. Okay, design and analysis of algorithm by Sandeep sir. ಅವ್ರು ಹೇಳಿದ್ದಾರೆ. Quickly, anyone can drop in either in chat box. I'm going to that one also. Else you can unmute yourself and you can define what exactly we can talk about merge sort. ಏನಿರ್ಬೋದು merge sort ಅಂತ? Quickly. Anyone? So as the name it says merge sort. So it means we will be given a problem. So the problem is sorting problem. So what exactly we need to do? We need to sort that by using merge sort. So how to do that one? So we need to do the sorting by using a divide and conquer method. Okay, so this is the method we need to use here, and in that method, this is the algorithm we are supposed to take. Okay, so some of you said a technique that uses divide and conquer strategy. Some of you said it's a divide an array into 2 phases, 2 halves. Okay, good. At least you're able to understand some of the technique or some of the strategy behind this merge sort. So merge sort, it mainly focus on divide and conquer strategy. It means what? You will be given a problem, a very big problem will be given, and that problem you're going to divide into number of sub problems. Okay, and after that one, you will start resolving that sub problem. That is said to be what? To conquer. If that sub problem is also a big problem, then again we will apply the divide and conquer strategy for that sub problem until we will get what one scenario wherein we can solve that sub problem. So ಸಣ್ಣ sub problem ಮಾಡೋ ತನಕ ಹೋಗ್ತೀವಿ. We'll get a very big problem and we'll divide that into a sub problem, and if it is solvable then it's well and good, we can solve. If it is not solvable, then again we will divide that sub problem into a number of sub problems. Then we'll apply the strategy until we can solve what the sub problem. So once we can solve the sub problem, then it is said to be what conquer. So then we're going to get what the solution for those sub problem, and those solutions will be merged together. So after merging all the solutions, that is of a sub problem, we will be getting a solution for the main problem. So that is said to be what? The merge sort. Okay. So now the same thing you can see here. I have a PPT for you. So just go through that one. It's with respect to sorting. Oh, this is merge sort and quick sort. So here we have a sorting algorithm. So we know different sorting algorithms. So insertion, selection sort, bubble sort, quadratic burst, all those things we know. But we have something called what the merge sort and quick sort, because it is going to consume less time compared to what these things. Okay. What exactly the merge sort it is going to do? It's going to apply what divide and conquer to sorting problem. So it will be given n elements. We're going to divide that problem until we will get what a sub problem, and that sub problem you can solve it. So ಆ ತರ ನೀವು ಡಿವೈಡ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀರಾ. So once you get what a sub problem. So in our case, what is the sub problem? Sub problem size should be equal to 1. If it is greater than 1, we will divide that problem into 2 halves. Okay, here to divide, we will divide the problem into two subproblems. Okay. Then when we have a problem with the size 1, then we will solve it. Then after solving two subproblems, we will merge it. Okay. Or then we will be getting what a solution to the main problem. So here we have the case. Let me directly take you through the case. So we have the problem here. So 10, 4, 6, 3, 8, 2, 5, 7. So this is the problem. So now we need to sort this one by using a merge sort. So when I say sort this one by using a merge sort, I need to divide this whole problem into two subproblems. Okay. So we need to divide this very big problem into two subproblems like this. 10, 4, 6, 3 becomes at the one side, and this will goes in one more side. Again, we'll check whether it's a big problem. Yes, it's a big problem. So when we can say it's a very small problem, so that we can solve. So if you get a problem with subproblem with only one element in it, then we can say what that can be solvable. So as it's not having only one element in, so it's having four elements. Again, we need to apply our divide and conquer strategy, wherein again I will divide this problem like this. Then after this one, we'll be getting the subproblem like 10, 4, 6, 3. And again, as it's not a subproblem which is solvable, then again I will apply divide and conquer strategy. I'll be getting a subproblem which can be solvable. So now it's been divided into 4 and 10, so which can be solvable. So solving in the sense what? So I need to sort. So while sorting, I need to sort in ascending or descending order. So if you want to sort in ascending order, so it should go in a decrease. It should go in an increased manner. So here we have 4 and 10. So after merging this one, we will be getting the result as 4 and 10. And then this is the solution for this problem. So 10, 4. It's been after solving, you will be getting it as a 4, 10. Then after coming to here, so after solving 6, 3, we will be getting 3, 6. Then we have what solution for this problem as well as this problem. By combining the solution of these two, so we will be getting the result as 3, 4, 10. Sorry, 3, 4, 6, 10. So 3, 4, 6, 10 will be acting as a solution for this problem. Understood? Then we will come to the right side. We have a problem here, and again the divide and conquer strategy will be applied until we will get what a one element. Then that will be solved. So we will be getting 2, 8 here and 5, 7. And again, after combining this one, we will be getting 2, 5, 7, 8. Okay, here we have 2, 5, 7, 8. And here we have 3, 4, 6, 10, and that will be combined. And after combining, we will be getting the result as a sorted result. Okay. So this scenario you can see here. Yeah. Let me show the thing which is going to happen in the merge sort. Okay, you can see the problem, the whole thing as I said. So 8329 and 7154, it's been divided until you get what single problem. Okay, and from here till here, it is a stage. It is said to be what dividing, and after this one, whatever the stage you can see, it is said to be what combining. That is what we say merge. So while merging, it will be merged in a sorted manner. So 8, 3 will be compared. So we'll be getting it as 3, 8. And here 2, 9 will be compared. It's 2, 9. Then after that one, 3, 8 from here and 2, 9 from here. So it's been compared properly. Then we'll be getting the result as 2, 3, 8, 9. Then coming to the right side, this problem will be divided till here. And after that one, it will be merged. While merging, strategy will be applied for sort. So 1, 7. And here we have 4, 5. Then again, these two will be taken as a solution of the problem, and it will be merged, and we'll be getting it as 1, 4, 5, 7. And these solutions, this one and this one, will be again merged together by applying sorting strategy, and we'll be getting the result as like this. Okay, so this is an example of merge sort operation. Okay, we're going to do in the same operation. So this is the actual algorithm. So we have with respect to our merge sort, but in a detailed manner, we have the algorithm like this. Okay, this thing we're going to implement in our Java. So initially, we will be having a very big array. So a of 0 to n minus 1, and we will be having the index, the low and high. So what exactly we need to do? We need to sort array a of 0 to n minus 1 by recursive merge sort. So input, it's our array, okay, an array a of 0 to n minus 1 of orderable elements, and output, it's an array a of 0 to n minus 1, which is in a sorted, in non-decreasing order. It means in ascending order. Okay. So the definition of this merge sort algorithm is like this. So you will be knowing the low and high. Okay. Then what exactly we need to do? We need to find the mid value, as we are doing in the case of binary search. So what is mid? Mid is low plus high by 2. So after finding the mid value, so we will be saying that the whole array is being split into two halves. The one half from low to mid, one half from low to mid, and one more half from mid plus 1 to high. Understood? So we're going to apply the merge sort recursively until we will get what has problem with only one element. So it will be called by itself. So it's a recursive function. So merge sort, it is going to call the same function until it is going to get toward the condition with only one element. So that will be checked with this terminating condition, where low greater than high. If low and high are same, it means we have only one element. Then this recursion won't be applied. So after dividing the problem, both the problem which is at left side and the problem which is at the right side, after dividing the problem until we get what only one problem in it, then we'll start applying what the merge. Okay. So in this merge, we will be having an actual logic which is going to be applied in order to sort the elements from one half to another half. So both the half of the elements will be taken, and the logic will be applied with the help of this merge. And the parameters we need to pass for this merge function, it's mainly three things: low, mid, and high. Okay, low, it is from the starting index, and high is the last one, and the mid, it is for the combining purpose. Okay, so these things will be used in order to merge the two halves which has been taken as a solution for the sub problem. So other news to merge in merge sort will be that merge will be giving the solution for the whole problem. Okay, and the logic behind this merge is going in this manner. So before briefing about all these things, okay, I will play one video. You just go through that video, which will be helpful for understanding this merge sort in a quicker manner. So it's about 5 to 6 minutes. So we'll brief when it's playing. So this is the video we have with us for understanding the merge sort. So in the sorting algorithm, we use the idea of divide and conquer. We divide the array into two parts and sort them and then merge them to get the elements in ascending or descending order. So merge sort is done recursively. We take an array and keep dividing from the middle till we get only one element in each half. Okay, that is called subarray. Then we sort the subarray and join them back to get the final sorted array. So as I said, two halves per array, then we'll be getting the thing. So here we have the thing. It may sound a little confusing, but don't worry about the example. You will understand the whole scenario. So let's go for an example. So this is an example wherein easily we can understand merge sort. So consider an array having 6 elements in it, 5, 4, 3, 1, 2, 6. Arrange the element. We need to arrange the element by using what merge sort. That is ascending order. Here we have array. Now this is the array with a value 5, 4, 3, 1, 2, 6, and this is the index 0, 1, 2, 3, 4, 5. So as you know this one. So we have BEG as a starting element index. We can take it as low, and END we have here as a end index for that array, and we can take this as a high. So low and high. So this is starting index and this is the last index. Now observe carefully. So this whole array will be divided by using what this division big plus n by 2. In our algorithm, we have taken it as a low plus high by 2. Okay, in order to find the mid. So we will be dividing now the same thing. So we'll check the condition. This is very important. If big is less than end, it means what we have more than one element until. If it is not true, then we have only one element. We are not supposed to apply what to divide and conquer. Okay. If it is true, if big is less than end, then we need to apply the divide and conquer. So actually we are doing what dividing the array into two halves. So mid is equals to big plus n by 2. So it is 0 plus 5 by 2. So mid will get it as 2. So it means what the whole array will be divided from 0 to 2 as one half and 3 to 5 as one more half. Okay. So as you can see now in this video, so it's been dividing now. So this is the first half. Okay, and now recursion will be taken on this first half itself. Okay, don't worry about the second half. So after completing this part, then control will comes here. So again, recursion will be applied repeatedly because of this condition. So again, this will be divided until we will get what one element in the subproblem. First left, then right, then quickly. First left half, then second right half. So now still it's dividing the problem because of the condition. Okay. Big and end, that is low and high. Again, it will be divided as the index with 0 and index with 1, so two halves. So then it will stop recursion on those things because of we have only one element here. So as we have only one element, recursion will be stopped. Okay. So then it will start merging it. So as we have got the solution for the subproblems, so now it will start merging it. So swapping options, position ಮಾಡ್ತಿದ್ದಾರೆ. So it's a logic. So ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ. So 0, 1, then we have solution for this problem. So we have solution for this problem. Okay, if problem is solution ಬಂದಿದೆ. Next, this problem will be taken. So as we have only one element, so now these two will be combined. While combining, it will sort the element. Okay. So this logic has been explained in class by sir. The same thing here. So now this part it's been sorted 3, 4, 5. Now control will takes the second half. Okay. So now control will takes the right subarray. This is the right subarray. So again, same strategy will be applied here. I think you are following. So same kind of strategy. So it is going to find the mid point, two halves, 0 to 1. Okay. Then again, it's going to divide this problem as two subproblems. So we'll be getting two subproblems. So left subarray. So it's having only one element, so it's a solution for that subproblem. So solution is only that one, and then control will comes to the right subarray. So that is also a solution. So now those two will be combined. That is merged by it will be merged. The merged result will be same 1, 2. Okay. So 1, 2. We will be getting the result as 1, 2 itself. Then control will comes to the right subarray of this problem. So here we have the element as 6. So control will comes to here. And as we have only one element in this one, so it will be in a sort way itself. So now these two subarray will be merged, and we will be getting the result as 1, 2, 6. Okay. So we have the result. The result is 1, 2, 6. Fine. Let me keep this, and I will explain how exactly the merging operation will act, what will work with an whiteboard concept. Okay. Let me get this scenario. Okay. So now I've taken this scenario on the whiteboard. So as you can see. So now observe carefully how exactly merge will work. So the merge operation I will write here. So we will be having two subarray. So this is array, first subarray and the second subarray. So the merging will be taken place like this. First element I will take from here. So this is the first element I will take from here, and this element will be compared with this. So Okay, so now I'll compare 3 with 1. This is the first subarray and this is the second subarray. So this is the result and result array. So here we will be getting the result. Okay, so 3 will be compared with 1. So which is smaller than this, smaller in this, it's 1. Okay, 1 is smaller than this. So I will be taking that 1 and it will be vanished. So 3 will be returned here itself. Then again this 3 will be compared with this 2. Okay, whether this 3 is smaller than this 2, no, 2 is smaller, so this 2 will be taken. Got it? So then again it will be removed from here. It means what, it's brought to the resultant array. Then 3 will be compared with the 6. So 3 and 6, 3 it's smaller than this 6, so 3 will be taken from here. So 3 will be taken. Then after this, the next element will be taken from this subarray and it will be compared with this. 4 will be compared with this. So as 4 is smaller than this 6, and this 4 will be taken to here. Understand? Then after that, we'll be taking this element 5. Then 5 will be compared with the 6, as 5 is smaller than this, so 5 will be coming here. And as we are not having any element in this subarray, so immediately what exactly we need to do, whatever the elements it's left out in this second half, so all those elements we need to write to the resultant array. So in the second half we are left out with only 6. That part I will write here, and this is the result of this whole problem. And the merging operation will be done like this only. Okay, so comparison ಮಾಡಬೇಕು ಯಾವ ಸಣ್ಣದಿದೆ ಅದು ಬರೀಬೇಕು. Last, if you won't have any elements here, then whatever the elements we are left out now here, so that should be returned to the resultant array. And it's vice versa. If you have an element, some elements you are left out here, and you don't have any element here, then again it's the same thing. So whatever the element you are left out, either here or here, we need to write directly. ಅರ್ಥ ಆಯ್ತಾ? ಯಾವುದಾದ್ರೂ ಒಂದು ಎಂಟಿ ಆಗಿ ಇನ್ನೊಂದರಲ್ಲಿ ಏನಾದ್ರು ಎಲಿಮೆಂಟ್ಸ್ ಇದ್ರೆ ಅದನ್ನು ಬರೀಬೇಕು. ಈ ಕೇಸು ಅಥವಾ ಉಲ್ಟನ್ ಆಗ್ಬೋದು. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್? So this is the approach we are supposed to use in merge. Okay, and the same thing we have in our algorithm. So you can understand now. I'll just project now. I think you are able to get this point. So initially we are going to divide the problem using mid, and then we are going to give a recursion to the left side and towards the right side. The right side and the mid plus 1. Understood? Then we are going to do a merge. In order to do the merge, we need low, mid, and high. So this is the merge algorithm, wherein we have I, j, k. Okay, as a variables, wherein I it's our low, j it's mid plus 1. It is for the first half, and this is for the second half. Understood? And this is for the counting purpose. And here we have the condition. Okay, it will be used in order to compare the element. So if a of I is smaller than a of j, then we will be taking the a of I to the result. Understood? Else we will be taking a of j to the result. ಯಾವ್ದು ಸಣ್ಣದಿದೆ ಅದನ್ನ. So this thing easily you can understand. Okay, it should be iterated until one of the array is going to be empty. Subarray. So ಯಾವಾಗ one subarray empty ಆಗುತ್ತೆ, then we will check whether it's a left subarray or whether it's a right subarray. If it is a left subarray, if the left subarray, if it is having some elements in it, then I will be taking all the elements which is there in that subarray. Okay, and suppose if the if some elements are left out in the right subarray, then I will take all those elements to the array. Okay, this will be done using these two value, and at the end we will be having the result in B. But what exactly we need to do? We need to get what the result in A itself. Okay, as output it says we need to get what the result in the same array. So I'm just copying whatever the elements I have, the sorted elements. Okay, all those things I'm going to get in array A. Okay, this is for just copying the elements from B to A. Okay, this is for comparing the element as you have done earlier. Swap, just compare madi. I need to get the element to the result. Okay, for that purpose. And this while it is for getting the elements which is there at the left subarray. It means what, right subarray ಖಾಲಿ ಆಗಿರುತ್ತೆ. We will be having some elements at the left subarray. So to get that one, this is the while loop. And to get the element from the right subarray, it means what, left subarray will be empty. So then we need to get what the elements from right subarray. Further, this is the while loop. And at the end, a result will be there in B, and that B result we are going to copy to A. Understood? So this is about our algorithm. Okay, so it's been discussed in class in depth. Anyway, I've taken in a quicker manner to understand about this one. Let's go for getting the thing with our Java. So now we'll start implementing it. So in order to implement here, I will take the algorithm directly, which has been explained now. That is there in this in the form of code. So then type my ಇಟ್ಕೊಂಡಿದ್ದೀನಿ. So I have the same thing here. So you can just do a comparison. This is the algorithm merge sort. Okay, uh, just focus. It's algorithm called merge sort, and the algorithm it's been converted as a function. If you know algorithm, easily you can write the function, and vice versa. If you know function, easily you can write the algorithm also. Ulta. Okay. So as I have algorithm here, and the same thing it's been converted as function, and you can see that function here. It's a wide merge sort. We have low and high. So we're going to compare low and high. If low is less than high, then I will proceed for finding the mid. Mid is equal to low plus high by 2. Then merge sort is equal to low to mid. Then low merge sort from mid plus 1 to high. Okay, this is for the first half, and this is for the second half. Then we are combining. So this is merge low comma mid comma high. Okay, this is the merge sort function, which has been discussed in algorithm. And we have one more algorithm, as I said, merge. So this algorithm again, it's been taken or implemented in the form of a function. So this is that function wide merge. So we have low, mid, and high. So I j k, I is equals to low, j is equal to mid plus 1, k is equals to low. And this is the iteration we're going to do with respect to y in order to do what a comparison and getting the result to p. Okay, so compare ಮಾಡಿ ತಗೊಳ್ತಾ ನಾವು ಮಾಡಿದ್ವಲ್ಲ ಅಲ್ಲಿ. And this while it is for getting the element from left subarray. It means right subarray will be empty. And this while will be used to get the element from right subarray. It means left subarray will be empty. And this is a for loop wherein we are getting the result which is there in B to A. But then we are copying to A itself. Understood? So these two functions I will simply get and paste in my code. Before that, let me create a file in our Java. So I have launched workspace for the DAA lab. Yeah, ಅದಕ್ಕೆ launch ಮಾಡಿರೋದು. So my merge sort will give the main class name as my merge sort. So public static void main will finish. So this is our class my merge sort. Then we will get class merge sort here. So this is class merge sort. Under this one we will get two important things. Array. So I need array A of type integer. Then I need array B of type integer. Then I need n. This is for the purpose of getting size for the array. Okay. Then after this one, we will get a constructor merge sort. In this constructor, I'm going to get a size from the main method, but we need to initialize here. So let me have one scanner in main method. Focus ಮಾಡಿ ಬೇಗ new scanner system.in. It's all known for you. ಹಾಗಾಗಿ ಸುಮ್ಮನೆ ಫಾಸ್ಟ್ ಅಲ್ಲಿ ಹೋಗ್ತಾ ಇದ್ದೀನಿ. So I need to get the scanner. So we'll import that scanner. Okay, it's been imported. Now here locally I will take one more variable. Say size. I will take this is for the purpose of reading size in main method. Sys out. Here I will give enter the size. Enter the number of elements. Take enter size. Then I will be reading the size for a variable called size is equals to ssc dot next thing. And now I have size. So now keeping this size with us, then we will create object for class called merge sort. Merge sort. Let's say this as ms object. New merge sort of this size. Understood? So this is the thing. So this is a class. In this class, we have a parameters constructor. So for that, I'm passing this. So now your size will come and it will be caught in SZ, and internally it should be assigned to N. Okay. Then we have array A and B. We need to allocate the memory for A and B dynamically with the help of that size. So I'll be taking that N, and I need to allocate the memory for A and B like this. I'm allocating it. So it's been allocated. Memory allocation also, and we know what is N value also. So immediately after this one, I will get those two methods which has here. So I'll simply get these things. So I have merge. Okay, this is merge. I will just paste here, and this is our one of the member function. Remember, or these are all data members. This is our constructor, and this is one of the member function. Okay, we have array A, B, small merchant because it's been small. No, middle small is the handle. So we'll make it as small. Understood? That's it. It's been done. So we are done with the merge. Then I will get the code with respect to merge sort method. Just get it here. This is our merge sort. Okay. So we are done with the merge sort also. Now apart from this, I need to get two more methods. One is for reading the elements, and one more method I need that is for the display. Okay, read method, display multiple. Let's proceed and get those definitions. The first method I'm supposed to get is a read method. So in read method we need to have a scanner. Okay, I'll get the method void read. So in read method I'll get the scanner. Scanner SC, it's a local, remember. SC is equals to new scanner system dot in. Okay, so we have a scanner. Then after this scanner we will be giving one message. So sysout enter the elements. I'll simply demonstrate how exactly this merge sort will work. So later we will change this program for element reading the element more than 5,000 like that. Okay, that we are going to do with help of random numbers. Okay, so enter the elements, and in order to read the elements, I will take the help of for loop. Int I is equals to 0, I less than n. Okay, we have for size, and I plus plus. Then here we'll read the element one by one. So a of 5 is equals to sc dot next int. Now we are reading the elements. So we have the elements with us now. So after this one, we can proceed for getting the display. Okay. So void the display. Void display. We have the method. So in display, we will simply display the thing again by using for loop. So I will use simply for loop. We will copy that for loop and paste here. We need to simply display the thing. So in order to display, I'll be using sysout. The elements I'm supposed to do. I'm supposed to display. So I'll display the elements with a tab. A tab I'll put display. So that's it. We have display with us, read, then merge sort, and the merge. And this is our constructor, and these are all data members. So after this, go to main method. So in the main method, we already created object. So after creating object, we need to call a method called read. So we need to read, right, the members. So read, it should be called. Okay. So then after read, I'll display the elements before sort. Before sort elements, authorize and threaded. So I'll say this as a before sort. The element will be displayed ms dot display. Then after this one, I will call mud sort. So this is the main function we are supposed to call. This is the function mud sort, wherein I need to pass low and high. We know what is low, so I will be calling that mud sort. So ms dot mud sort. So here I will be passing 0. 0 it's our low, and high is n minus 1. Okay. N is not there, so I will take this size, because here we are reading the value, that is array size to the variable called size minus 1. Then after that one, we will be getting the sorted result. So that sorted result I am going to display here. So before sort, then after sort. Okay, and I will be calling the same method, ms dot display. So that's it. So we have created object. Okay, how exactly we created? Before that, we read the size for the size. We need size. Okay. Then after that we called read. Then we will be displaying that unsorted array. Then we are going to sort that one by calling mud sort with 0 comma size minus 1, that is low and high. Then the sorted array will be displayed. So that's it. We'll save this. We don't have any errors here. So we'll go for run. So it will ask for the size. Let me give some size as 5. The 5 elements I'm supposed to sort now. So we'll give elements like this. Okay. So we have the elements with us 40, 30, 10, 50, and 20. So let's see. It's been sorted on. Yes, it's been sorted. So we have 40, 30, 10, 50, and 20. And it's been sorted as 10, 20, 30, 40, 50. But we are getting a line, right? So in separate line, we are getting the result. What exactly I need to do here? So while displaying, we need to display as print only, not print ln, because we have tab here, Saku. So we'll rerun this one. Oh, here I will take 5 with the elements, say 50, and 30, 10, 40, then 20. So this is the thing. So before sort and after sort. Okay. So we have just done through mud sort algorithm mugitu. So after this one, we have to discuss much more things. So it's just a basic. We're done with the algorithm. You have only algorithm. So we need to start applying what the things which has been asked in the problem statement. So what and all they are asked. Sort a given set of integer elements using mud sort. So we are just done sorting the element by using mud sort. So and compute its time complexity. We need to compute the time complexity. So in order to compute the time complexity, okay, we need to have a proper approach. So how to find the time complexity? So in order to find the time complexity with respect to our Java, okay, we will be finding the time complexity by using what the method called nano time. So we will be dealing with our system time itself. So system time on the double time. Okay. So we will be finding the time complexity of any function like this. Okay. So how to find the time complexity of a task? Say I have a task called merge sort. So if you are asked to find what is the time taken to execute that merge sort, ನಿಮಗೆ ಕೇಳಿದ್ರೆ ನೀವು ಹೆಂಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ just focus here. So it's a very simple approach. So here you have a task. Understand? So we have a task here, and by using you need to find how many there is time taken to execute that particular task. Say the task in our case it's a mud sort. ms dot it's a mud sort. So this is the task of 0 comma size minus 1. So this is the task. So what is the time taken in order to execute this particular task? So how exactly we need to find the time? So I will do a very simple thing here. So I will be taking mainly 2 timers. Here at time ತಗೊಳ್ತೀನಿ. The time which is before calling this mud sort. Okay. So before calling this mud sort, I will start one timer. Okay. I will be storing that time in the variable called start. I will take one variable called start, and I will store the system time. So system time before calling this method, I will store that time in start. Okay. So I will store that time. So for example, now the time it's 3:15. So that particular time will be stored, and here it will be storing what it's nanosecond. So ಬರೀ minute to hour ಆದ್ರೆ ಆಗೋದಿಲ್ಲ, because our system will be too fast. So let's take for example our system time right now it's 3:15. So I'll be storing that value in the variable called start, and then I will invoke the task. This is the task, and after completing the task I will take once again the system time. So in the variable called end, I'll be storing that time in the variable called end. And now in this moment, again I will capture the system time. Say now the system time in this particular time, in this particular situation, say it is 3:17. Understand? So now tell me, what is the total time taken by this function to execute? What is the total amount of time it is being taken to execute this particular task? Is to, what is the time? Anyone? Anyone? It's very easy. What do you think about the total time consumed by this operation, that is merge sort? One task ಆಗ್ತಾ ಇದೆ ಇಲ್ಲಿ. So what is the total time taken by this? Anyone? The time taken. The time taken is what? Am I audible? Am I audible? You can speak. Anyone? Am I audible? Yes, very good. Some of you said it's 2 seconds and some of you said 2 minutes. So in our case, it's 2 minutes. Minutes allirodrinda. So it's 2 minutes. So how exactly we need to find that one? So we need to do what? End minus start. Okay, if I do end minus start, I'll be getting what a total time taken. Okay, this is the approach I'm going to use in order to find the time complexity in our case. Remember, we won't be getting the time in terms of minutes and hours. Okay, we're going to get the time in terms of nanoseconds, because our system processor will be so much fast. ತುಂಬ ಫಾಸ್ಟ್ ಅಲ್ಲಿ ಎಕ್ಸಿಕ್ಯೂಷನ್ ಆಗುತ್ತೆ, ಹಾಗಾಗಿ ನಿಮಗೆ ಮಿನಿಟ್ಸ್ ಅಲ್ಲೆಲ್ಲ ಬರೋದಿಲ್ಲ. We will be getting the thing in terms of nanoseconds. Got it? Okay. So that thing I will do now. Just focus carefully. Okay. So let's proceed for getting the same thing here. So ಯಾರ್ದು ಮೈಕ್ರೋಫೋನ್ ಆನ್ ಆಗಿದೆ ನೋಡಿ. Okay. So I'll get the thing in the code now. I will go for the code. So as I said, here I need start and I need end also. So this is start and this is end. So in order to get the values in it, I need to declare these things. I will declare it as long, because we will be getting the time in terms of very large value. So start and end. And after this, I need to find the total time taken. Okay. I will find it by doing what a simple subtraction. Start, that is n minus start. So what exactly we need to get in this start and end? Okay. We need to get the nano time of the system. So system nano time I need to get system dot. So we have the function called nano time. So you just get it. So it will capture the system current time in that particular, in the time of executing that particular statement. Okay. So nano time. So that's it. It will captures the time. Then after sort, we will be displaying the result. Then after this one, we will do the statement sys out, and I will display total time taken. Total time taken, or you can say simply time taken. Time taken for sorting. Okay, so you can display that by doing the simple subtraction end minus start step. Right? Okay, so this is in order to find the time taken to execute this operation. So this is our main operation. Okay, so you're not supposed to start your timer from here itself. So ಇಲ್ಲಿಂದನೇ start ಮಾಡಬೇಡಿ timer because it's a wrong concept. So if you start from here, it is wrong because here we are reading the size of array. So size of array ಅಂತಂದ್ರೆ we need to read through keyboard. ಕೀಬೋರ್ಡ್ ಇಂದ ರೀಡ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಯೂಸರ್ ಒಬ್ಬೊಬ್ರು ಒಂದೊಂಥರ ಎಂಟರ್ ಮಾಡ್ತಾರೆ. ಅಂದ್ರೆ someone will fast typely, and someone will very lazy manner they will give the input. So all those things will be factors which is going to affect for the algorithm. So algorithm time vary agibidutte. Okay, so we won't be doing that. We won't be starting our time for all those things. Okay, even for reading, even for displaying. So for those things, we are not supposed to apply this time complexity computation. We need to only focus on the main task. This is our main task, merge sort. Okay, for that, you just start the time and end the time. Then find the difference. So let me run now. Return. So it's asking for the size. If I give 5, ಬೇಗ ಫಾಸ್ಟ್ ಆಗ್ಬಿಡುತ್ತೆ ಅನ್ಸುತ್ತೆ. 5 ಎಲಿಮೆಂಟ್ಸ್ ಅಷ್ಟೇ ಅಲ್ವಾ? Won't feel much more the time taken. So this is the time taken. So it's taken 15,200 nanoseconds. Understood? So this is the total time taken for sorting. Okay. So now in the same manner, we need to compute the time taken for n elements, where n should be greater than 5,000. So this is the next thing we have. So n should be greater than 5,000. It means what? We are not supposed to give the input through keyboard. All those 5,000 elements now ಕೊಡಕ್ಕಾಗೋದಿಲ್ಲ. It's tedious. So what is the options they are given? So in order to read n greater than 5,000 elements, so they have said that you can read through 5, or you can take the help of a random number generator. So we will take the help of a random number generator. So that will be very easy for us. So here in order to read the elements through a random number generator, so we have a class called random. So I'll take this as R and new random. Okay. So we'll take the help of this particular class. Then we'll start reading what the values. Right. So this is that particular class, new random. So we need to import this particular package that is there in util itself, util random. So this is the class. So now by using this random, we can read the elements. So instead of SC, now you can read values by using what R. Okay. I'll just copy and paste here. We'll just comment it. This is for the purpose of reading the input through keyboard. You can input in read ಮಾಡ್ತಾ so I'll comment this also and I'll comment this also, and now I'll read the element through random number generator. Okay, so for that we need to use R dot next int. Okay, you use just this R dot next int. So it is going to read what the random number automatically between the range, whatever the value we have n. Okay, that will be taken as a range from 0 to n. So between n minus 1, 0 to n minus 1, between that range, it is going to generate the numbers. Okay. So let me run the thing now, wherein I am reading the value through random number generator. So this is the thing we need to do. So we need to import that package and this class and create an object for that. And this is the approach, r.nextInt. Okay. So this sc.nextInt, this is for reading through keyboard. So we'll run. Now we'll give the size here, and give the size as 10, and this is the thing. Okay, so we are getting the values here, but these values are not understandable. So it's been randomly generated and it's been sorted. But in order to get what a proper valid value, so what I will do, I will give the range. So I will give the range as n here. So n in the sense between 0 to n minus 1. So n 10 and 0 to 9, like that. If within that range, it will generate the random number. So let me run. So as I have given 10 here, so it is going to generate the random number between 0 to 9. So this is the thing. So we have the random number. So all these are random numbers. Million ella random number, which is an unsorted way. Okay. And after sort, we have the result. Understand? So while generating, it is going to generate what a redundant value, duplicate values for both. And at the time of sorting, it will sort in a proper way. So you can just take a glance on these random numbers. And here we have the result after sort. And this is the total time taken for sorting. Understand? Okay. So now what exactly we need to do? So we are almost done with this random number generation, time taken, sorting algorithm. What exactly we need to do? We need to start reading what a value which is greater than 5,000, as you said. So initially, you need to check whether your program is working or not, like this. You need to start giving what the value 5,000. If I give 5,000, it means what? It will generate a random number between 0 to 4,999. Okay, our range will generate ಮಾಡುತ್ತೆ. So it's been generated. So these are all the generated random numbers. Understood? And this is sorted one. So you can see the value. I'm just scrolling here. Okay, it's been sorted. Last 4,999 ಬರೋದು. Starting ಅಲ್ಲಿ 0 1 ಹತ್ರ ಬರ್ತಾ ಹೋಗುತ್ತೆ. 0 generate ಆಗಿಲ್ಲ. And here we have the total time taken. Got it? So after this one, what exactly you need to do? You need to construct one table. One table construct ಮಾಡಬೇಕು. Okay. What exactly that the table it should have? In that table, you need to have the parameters, that is attributes. So you need to construct one table like this. So you throw one table ಮಾಡಿ, and this is n, and this is time taken. Okay. This is n, and this is time taken, and initially n should be 5,000, and what is the time taken? ಅದನ್ನು ಬರ್ಕೊಳ್ಳಿ. Then after this, with an interval 500 to 5,500 ಅಂತ input ಕೊಡಿ. What is the time taken? Note on it. Then 6,000. Then note on the time. 6,500. Note on the time. Then 7,000. Note on the time. 7,500. Note on the time. And 8,000. Okay. Stop for at least 8 readings. 8 to ಆ ಥರ ಇಟ್ಕೊಳ್ಳಿ. Stop ಮಾಡಿ. So you will be getting the time taken. So now what we need to do? We need to plot a graph. So we need to plot a graph. So the plot of graph should be done like this. So n versus time taken. So he has given in the statement. Okay, statement alle helidare. Record the time taken to sort. Plot a graph of the time taken versus n. So here we'll be having n. Understand? Okay, and here we'll be having a time taken. So this is time taken. So this is n. Okay, this is n. This is time taken. Right. We'll be having here it has 5,000. Then this has 5,500. This has 6,000. 6,500. ಈ ಥರ. Okay. And here we'll be having a time taken. The ನೀಟಾಗಿ ಸ್ಕೇಲ್ ಮಾಡ್ಕೊಳ್ಳಿ ನೀವೇ. ಸ್ಕೇಲ್ ಮಾಡಿಕೊಂಡು ದೆನ್ ಯು ನೀಡ್ ಟು ಪ್ಲಾಟ್. ಸೊ ಪ್ಲಾಟ್ ಮಾಡ್ತಾ ಹೋಗಿ ವ್ಯಾಲ್ಯೂ 5,000 ಇಲ್ಲೆಲ್ಲೋ ಇರುತ್ತೆ ಈ ಥರ. It will start from somewhere here. It won't start from this point. Then we will be getting something here. Then we'll be getting the value something like this. So it will goes in almost like a n log n. The time complexity of merge sort. It's a big O of n log n. ಗೊತ್ತಿದಲ್ವಾ ನಿಮಗೆ? Okay, n log n to the base 2. So this is the time complexity of a merge sort, and this plot will goes in the same manner. Okay, this is n log n. Understand? Why base 2? Because of divide and conquer. Divide ಎರಡು ಆಲ್ಫಾ ಆಗುತ್ತಲ್ಲ ಹಾಗಾಗಿ. Understood? This is n log n. So the plot will goes in the same manner. ಸ್ವಲ್ಪ ಆ ಕಡೆ ಈ ಕಡೆ ಹೋಗುತ್ತೆ. ಪಾಯಿಂಟ್ಸ್ ತುಂಬ ಆ ಕಡೆ ಇದೆ, ಅದನ್ನು ಬಿಟ್ಟಾಕ್ಬಿಡಿ. ಈ ಥರ ಹೋದ್ರೆ ಬಿಟ್ಟಾಕಿ ನೆಕ್ಸ್ಟ್ ಲೈನನ್ನು ಜಾಯಿನ್ ಮಾಡಿ. And while joining these points, you need to join free end. Don't use scale. Scale use ಮಾಡಂಗಿಲ್ಲ. You need to join like this. It's a free end ಅಲ್ಲಿ. Got it? We need to plot this graph also, and you need to upload this one. So today you are supposed to upload mainly 3 things. One, the source code. Second one, a screenshot of the result. The third one, graph. So 3 things you are supposed to upload. ಗ್ರಾಫ್ ಶೀಟ್ ಇಲ್ಲ ಅಂತಂದ್ರೆ ಏನು ವರಿ ಮಾಡ್ಕೋಬೇಡಿ. ಯು ಟೇಕ್ ಒಂದು 100 ಪೇಜ್, ಅದರಲ್ಲೇ ನೀವು ರಫ್ ಆಗಿ ಒಂದು ಮಾಡಿಬಿಟ್ಟು ಅದನ್ನು ಪ್ಲಾಟ್ ಮಾಡಿ ಹಾಕಿದ್ರೆ ಆಯ್ತು. ಸ್ಕೇಲ್ ಇಟ್ಕೊಳ್ಳಿ ಅಷ್ಟೇ, ಸ್ಕೇಲ್ ಬೇಕು ನಮಗೆ ಮೇನ್. So just plot and you need to upload. So you need to upload 3 things in of today's Google Classroom assignment. Okay. So fine. We have done with the statement. So what and all we have completed? Just go through the statement. We need to sort a given set of integer element using mud sort. We are done with that, and we also computed time complexity. We are done with this one, and we also run the program for varied value of n greater than 5000. We also done this. We have recorded the time taken to sort, then we need to plot the graph. So this also we are done. The elements can be read from this also we are done. Then we need to demonstrate this one. So we need to demonstrate using Java how the divide and conquer method works along with its time complexity analysis for the worst case, average case, and best case. So we have mainly 3 types of time complexity analysis. It's called worst case, average case, and best case. Okay. So let's quickly go and get the meaning of this one. So ಏನಂತೇಳಿ. So before that, let me run the program for varied value of n. So here we have for 5000. So let me run for 5500 and observe the time taken. I want to vary. Okay. So if I take 6000, so this is the input and the output and the time taken. ಟೈಮ್ ಟೇಕನ್ ಸ್ವಲ್ಪ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಚೂರು ಲಾಸ್ಟ್ ಟೈಮ್ಕಿನ ಕಡಿಮೆ ಟೈಮ್ ಬರ್ಬೋದು ಬಿಕಾಸ್ ಆಫ್ ದ ರ್ಯಾಂಡಮ್ ನಂಬರ್ಸ್. ಈ ರ್ಯಾಂಡಮ್ ನಂಬರ್ ಯಾವ ಥರ ಜನರೇಟ್ ಆಗಿರುತ್ತೆ ಅದ್ರ ಮೇಲೆ ಹೋಗುತ್ತೆ. ಆ ಥರ ಇದ್ರೆ ಇನ್ನೊಂದ್ಸಲ ರೀರನ್ ಮಾಡಿ ನೋಟ್ ಡೌನ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಬಟ್ ಯು ನೀಡ್ ಟು ಗೆಟ್ ದ ಪ್ಲಾಟ್ ಸಮ್ವಾಟ್ ಲೈಕ್ ದಿಸ್ ಒನ್. ಇದೇ ಥರನೇ ಬರುತ್ತೆ, ಅದು ನೋಡ್ಕೊಂಡು ಮೂವ್ ಮಾಡಿ. ಓಕೆ. ಸೊ ನಾವು ಲೆಟ್ಸ್ ಪ್ರೊಸೀಡ್ ಆ್ಯಂಡ್ ಟ್ರೈ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಡಿಫ್ರೆಂಟ್ ಕಾಂಪ್ಲೆಕ್ಸಿಟಿ, ಟೈಮ್ ಕಾಂಪ್ಲೆಕ್ಸಿಟಿ ಅನಾಲಿಸಿಸ್. ವಾಟ್ ಯು ಥಿಂಕ್ ಅಬೌಟ್ ದ ಬೆಸ್ಟ್ ಕೇಸ್? ಬೆಸ್ಟ್ ಕೇಸ್ ಏನಿರ್ಬೋದು ನಿಮ್ಮ ಪ್ರಕಾರ? ಸೊ ರಿಮೆಂಬರ್ ಆಲ್ ದೀಸ್ ಕೇಸಸ್ ವಿ ಗೋನ್ ಟು ಡಿಸ್ಕಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದ ಇನ್ಪುಟ್. ಹೌ ಎಕ್ಸಾಕ್ಟ್ಲಿ ವಿಲ್ ಗಿವ್ ದ ಇನ್ಪುಟ್. ಇನ್ಪುಟ್ ಯಾವ ಥರ ಕೊಡ್ತೀರ ಅನ್ನೋದನ್ನ ಕೇಸ್ ಹೇಳುತ್ತೆ. ಓಕೆ. ದಟ್ ಈಸ್ ವರ್ಸ್ಟ್, ಬೆಸ್ಟ್, ಆವರೇಜ್. ಆಲ್ ದೋಸ್ ಥಿಂಗ್ಸ್ ವಿಲ್ ಬಿ ಡಿಟರ್ಮೈನ್ಡ್ ಬೇಸ್ಡ್ ಆನ್ ದ ಇನ್ಪುಟ್. ಸೊ ಹೌ ಎಕ್ಸಾಕ್ಟ್ಲಿ ದ ಇನ್ಪುಟ್ ವಿಲ್ ಗೋಸ್ ಟು ದ mud sort. So tell me what exactly the meaning of average case, best case, and worst case in your scenario. First tell me. So what is the best case? What is the best case input for the time complexity analysis? Enable. Anyone? Quickly. Just unmute your mic and you can speak. So what do you think about the best case input? Best case input ಏನಿರ್ಬೋದು? Anyone? What do you think about the best case input? ಇದೆಲ್ಲ ಹೇಳಿಲ್ವಾ ಅಲ್ಗಾರಿದಮ್ಸ್ ಅಲ್ಲಿ? ಸರ್ ಎಲ್ಲ ಇದನ್ನ ಹೇಳಿರ್ತಾರೆ ಮೋಸ್ಟ್ಲಿ. It's all depends on the input. The worst case, best case, and average case. All those things, it depends on the input. Input ಯಾವ ತರ ಕೊಡ್ತಾರೆ ಅದ್ರ ಮೇಲೆ ಕೇಸಸ್ ಹೋಗುತ್ತೆ. So what do you think about the best case? Best case ಅಂದ್ರೆ ಏನಿರ್ಬೋದು? So we'll give detail about one case. One case ನಾನು ಹೇಳ್ತೀನಿ, ಇನ್ನು 2 ಕೇಸ್ ನೀವು ಹೇಳಿ, ಆಯ್ತಾ? So what exactly the meaning of best case here is? So we are trying to sort what elements in ascending order, right? So what should be the best case input here? The best case input, it is input which is already in a sorted manner. Sorted manner alliro elements ನೀವು input ಕೊಟ್ಬಿಟ್ರೆ, so that is going to be a best case. Okay. So let me demonstrate that one. So the best case. So best case is this one itself. If the input, it is going to be in a sorted manner. So AFI is equals to I. Right. So what is AFI? AFI is I. It means 0, 0, 1, 2, 3, 4. If n is 5, so 0, 1, 2, 3, 4. So we'll be having in array 0, 1, 2, 3, 4 itself. Understand? So it means what? So it, whatever the element we are getting, all those things, it's already been in a sorted manner. Okay. So let me run this, and you can see here. So if I give the size, If you give the size as 5, and this is the thing. So before sort it's 0, 1, 2, 3, 4, and after sort it is 0, 1, 2, 3, 4. So this is the best case analysis, time complexity analysis. Okay, input to sorted and output are the best one. So then what about average? Better, worst really. What about the worst? This is the best. Best in the sense ನೀವು ರಿಸಲ್ಟ್ ಸಾರ್ಟ್ ಹೆಂಗ್ ಮಾಡಬೇಕಿತ್ತು ಅದೇ ತರ ಇನ್ಪುಟ್ ಬಂದ್ರೆ it is best. What about the worst case? So what should be the worst case input?
Elements in decreasing order.
Yes, if it is going in a reverse manner, okay, then it's a worst case. So let me show that. So the worst case, a of I is equal to n minus I. Understand? N minus I. So this is the worst case. N andre it's 5. 5 minus 0 is 5. 5 then 8 is going to be incremented 4, 3, 2 like that. It will goes in that manner. Now let me run this. So if I take 10, so this is the worst case input. ನಮಗೆ ಬೇಕಾಗಿರೋದು ಅಸೆಂಡಿಂಗ್ ಅಲ್ಲಿ, ಇನ್ಪುಟ್ ಬರ್ತಾ ಇರೋದು ಡಿಸೆಂಡಿಂಗ್ ಅಲ್ಲಿ. Understand? If you have the thing like this, then this is said to be what worst case analysis. Understand? You're supposed to demonstrate like this only. Exam ಅಲ್ಲಿ ಇದೇ ತರನೇ ಮಾಡಬೇಕು. ನಾನು ಇಲ್ಲಿ ನಿಮ್ಗೆ ಏನು ಮಾಡಿ ತೋರಿಸ್ತಿದ್ದಲ್ಲ ಇದೇ ತರನೇ ಮಾಡಬೇಕು. Then what about the average case? Average case ಅಂದ್ರೆ ಏನು? So I have detailed about best case. Best case in the sense, so in which order you want the result, and in the same order if the input comes, that is the best. And what is the worst? In which order you want to get the result, but if the result input, if it is coming in its reverse order, then it is the worst. What about the average? What do you think about the average? In average andre
They're neither in ascending nor in descending order.
Yeah, randomly like this. This is average. So it's coming in a random manner. It is not either in ascending or descending. Okay, so this is called one average case. Understand? So you can see if I run with the value as 10, so we are getting what the elements here. It is in a random manner. So and the result is this. Okay, so this is all about what the analysis of time complexity. This is for the best, this is for the worst, and this is for the average. Okay, and we have this statement. Why we have this statement? In order to check whether our algorithm is working or not. So ಅದಕ್ಕೆ ಇದನ್ನ enable ಮಾಡ್ಕೋಬೇಕು first time. ಆಮೇಲಿಂದ ಇದನ್ನ ಯೂಸ್ ಮಾಡಕ್ಕೆ ಹೋಗಬೇಡಿ. You need to completely deal with what this random for plotting, and we need to use again these three for demonstrating worst, best, and average case. Okay. So that's it. It's all about our lab assignment. We are done with this. Okay, so completely we are done with this one. And our quick start also, it will goes in the same manner. Same, ಇದೇ ತರನೇ. Only the thing is here, instead of merge sort, we will be using quick sort, and we will be doing the whole process in the same manner. Okay, whatever I have explained, in the same manner it will goes. Fine. So that's it about today's lab session. So if you have any doubts regarding this lab assignment, you can ask. You just unmute your mic and you can start asking the questions if you have. Else we will wind up the session. Before that, we will speak with Artiman. Any doubt idea? If you have any doubt, you can ask. Okay. Is all of you enrolled for Google Classroom? So ಯಾರು enroll ಆಗಿಲ್ಲ ಅವ್ರು enroll ಆಗ್ಬಿಡಿ. Because everything will be discussed through that Google Classroom itself. Okay. So we'll ask Aarti ma'am about last week status. If there is any issues, she will address. Aarti ma'am. Aarti ma'am, idira? Aarti ma'am, idira? It's okay. It's not there. Fine. So if there is no issues, we'll end the session. I will ask Sandeep sir to create 3 assignment for today's lab session. You're supposed to upload source code, or you're supposed to upload screenshot of the result, then the graph also. You need to do all those things. Okay. Then we'll end the session. Just drop your attendance and leave the session.
ಸರ್ ಲೀವ್ ಆಗದಾ?